everyone, I'm an AI engineer, and here on this channel, we love to break down really complex AI tech and make it super simple and clear. Today, we are diving into a model that's been making some serious waves. And what's interesting is, it's not because of its massive size, but because of how incredibly smart it is. It's called GLM-OCR, and honestly, it's a total masterclass in how to be smarter, not just bigger. So let's kick things off with a problem that, let's be real, we've all faced. Trying to pull useful information out of documents. We're talking invoices, reports, scientific papers, you name it. And it sounds like it should be easy, right? But for an AI, it's a huge headache because the meaning in a document isn't just in the words. It's hidden in the layout, the tables, the whole structure of the page. And that really gets to the core question. In an age of absolutely mind-blowing AI, why is this still so ridiculously hard? Well, it's because documents are not just a bag of words. That's a term we use for just a jumble of text where the order and placement don't matter. In a real document, where the text is can be just as important as what the text says.
And this slide right here perfectly shows the gap we're stuck in. On one hand, you've got your traditional OCR tools, like Tesseract. They're pretty good at just ripping plain text off a page, but they are completely blind to structure. You show it a table, and it just hands you back a total mess of words. Then, on the other extreme, you have these giant mega models like GPT-4V. I mean, they're incredibly powerful, no doubt, but they're also slow, super expensive, and honestly, using one to read a simple form is like using a sledgehammer to crack a nut. Total overkill.
This is the sweet spot. This is exactly where GLM-OCR comes into the picture. It was literally designed from the ground up to fill that gap, to be smart enough to understand all that complex structure, but also efficient enough to be actually practical in the real world. And when I say efficient, I really mean it. The whole model has just 0.9 billion parameters. Now, I know what you're thinking. Billion sounds like a big number, right? But in the world of modern AI, where models have hundreds of billions or even trillions of parameters, this is tiny. It's incredibly compact. But, and this is the important part, do not let that small size fool you. Because this is the wow moment. This chart is from OmniDocBench, which is a major industry benchmark for this kind of stuff. And sitting right there at the very top, number one, is our little 0.9 billion parameter model. It's outperforming giants that are dozens, even hundreds of times its size. This isn't just a little step forward. This is a totally different way of thinking about the problem. So just to recap what makes it so great, it's got that top-of-the-line, state-of-the-art performance. It's built specifically to handle the messy real-world documents you and I actually have to deal with. It's super fast and cheap to run, which is huge. And it's open source and comes with tools to make it easy for developers to actually use it. So, the big question is, how? How in the world does a model this small pull off such a huge feat? To understand that, we gotta pop the hood and take a look at its architecture. All right, let's dive in. The whole system uses this really clever two-stage approach. First, you have a layout detector. In this case, it's called pp.docLayout v3, that scans the document and basically draws boxes around all the important stuff. Paragraphs, tables, formulas, you name it. It chunks the complicated page into a bunch of simpler mini-problems. And then, the main GLM-OCR model comes in and processes all of those chunks at the same time, in parallel, which gives it a massive boost in speed and accuracy. Now let's zoom in on the core model itself. It's what we call an encoder-decoder design. First, the CogVit visual encoder. That's about 0.4 billion parameters. It sees those image chunks and pulls out all the important visual details. Then, a tiny little connector acts like a translator, turning those visual features into a language the decoder can understand. And finally, the GLM language decoder, at 0.5 billion parameters, reads those translated features and writes out the final structured text, like Markdown or JSON. But okay, here it is. This is the real secret sauce, the thing that makes it so fast. Multi-token prediction, or MTP. See, most models generate text one token at a time. It's slow. MTP lets GLM-OCR predict a whole bunch of tokens in a single shot. The best analogy is this. It's like writing entire words or even phrases at once instead of just typing one letter at a time. It's perfect for things like tables, where the model can just predict the syntax for an entire row all at once. And that just brings us right back to our main theme, doesn't it? This isn't about throwing more and more computing power at the problem. It's about smart design, clever architecture, and specific optimizations that lead to these incredible efficiency gains. And the numbers absolutely prove it. Because of MTP, GLM-OCR spits out an average of 5.2 tokens every single time it thinks. The result? A whopping 50% improvement in overall throughput. It's just faster, plain and simple. And here's what that looks like in a head-to-head comparison. When it's crunching through PDFs, GLM-OCR can handle almost 2 pages every single second. That just blows away the other leading open-source models. For anyone building a large-scale system, that kind of speed is an absolute game changer. You know, I think this quote from the original research paper just sums it all up perfectly. It's not about the size, it's about the careful alignment of all the pieces, the architecture, the decoding strategy, and the task itself. That philosophy is what makes GLM-OCR so special. Okay, that's enough theory and charts. Let's see what this document understanding actually looks like in practice. Let's get to the good stuff. All right, so on the left, you've got this super dense customs form, a classic, messy business document. And on the right, that's the output from GLM-OCR. And notice, it's not just a big wall of text. It is perfectly structured JSON, with every single field correctly identified and pulled out. This is data you can immediately pump into a database or an application. No cleanup required. And if you think that's cool, check this out. This is where it really starts to flex. Here, it's looking at complex mathematical formulas from a research paper. It's not just reading the characters. It understands the 2D structure of matrices and fractions, and it translates all of it into perfectly clean, valid LaTeX code that's ready to go straight into another paper. Incredible. And that's really the main point here. The real prize isn't just getting the text. It's getting structured, logical, and instantly usable data. It's about understanding the meaning and the logic of the document, not just what's written on it. So let's bring this all home. For all you developers and engineers watching, what does this all mean? The most important thing is knowing you've got options and picking the right tool for the right job. Here's a simple way to think about it. If your main job is to process complicated, structured documents, things like forms, tables, scientific papers, and you need to do it fast and cheap, GLM-OCR is going to be your best friend. It does work best when you give it a clear template of what you're looking for, but it's fantastic at that. Now, if you need really strong multilingual support, something like Paddle OCR VL is a great choice. And of course, for those really creative, open-ended reasoning tasks where cost and speed aren't a big deal, the giant vision models are still the kings. And that kind of leaves us with a final thought to chew on. As we move forward, maybe the answer to bigger and bigger AI problems isn't always a bigger and bigger AI model. For so many real-world jobs, maybe a specialized, super efficient, and just cleverly designed model like GLM-OCR is actually the much smarter solution. And that's a wrap for this explainer. I really hope this gave you a clear look at what makes GLM/OCR so cool and so powerful. If you want to keep up with all the latest in AI, broken down in a simple way, make sure you hit that subscribe button. Thanks for watching, and I'll see you in the next one.